Hi everyone. Let's talk about IP addresses, domain names, and URLs in this module. Let's start by discussing IPv4, the original version of the Internet Protocol. IPv4 uses 32-bit addresses, which means it can support around 4 billion unique IP addresses. At the time of this inception, this number seemed more than adequate for the number of devices that would connect to the internet. However, with the explosive growth of internet enabling devices such as smartphones, computers, and IoT devices, and more, these 4 billion addresses have proven to be insufficient. Today, the pool of available IPv4 addresses essentially exhausted, leading to the end of this robust solution, and we need more addresses. Just to go over some examples. I'm sitting right over here. I'm using my own personal laptop that takes one IP address. I have my phone, so it takes another IP address. I have a secondary phone that I use for testing devices. For example, testing different mobile applications on that uses another IP address. I have a soundbox that connects over the internet. It uses another IP address. I have a printer right beside me. It uses another IP address. I have a work laptop that is separate to my personal laptop that uses another IP address. If I move over to further back, I have one Google Voice Assistant, like the Google Echo devices, Amazon Echo devices, that uses another IP address. The router, the mesh Wi-Fi network itself does have separate IP addresses. So in this house, there are three mesh Wi-Fi networks, so that uses three IP addresses. The TV uses another IP address. The gaming consoles like Xbox and PlayStation that I have, those use separate IP addresses. So me personally being one person, when it was designed when it was designed in the early 90s, they would think that I am one person, I have one personal computer, maybe my family members can use the same computer. I just need one IP address. That's it. Done. But as I just described, me having at least 20 IP addresses enabled devices with me right now, laying around this room. So imagine how many people there are and how many IP addresses do we need. So definitely IPv4s are going to, and so 4 billion is not a big number, very small number. Then to address this limitation of IPv4, we need IPv6, the next generation of the Internet Protocol. IPv6 uses 128-bit addresses, vastly increases the number of possible IP addresses. In fact, IPv6 can support 2 to the power of 128 addresses, which translates to around 3.4 into 10 to the power 38, or 340 undecillion addresses. I haven't even used undecillion apart from this class, this word. So you can imagine how many IP addresses that we can have with IPv6. These enormous numbers should be more than enough to accommodate the need of internet connected devices far into the future. Although IPv6 provides a much larger address space, IPv4 and IPv6 are currently coexisting. The transition to IPv6 is ongoing and will continue over many years, ensuring that all systems can gradually adapt to the new protocol. Let's start with the concept of domain names. A domain name is a user-friendly name representing of an IP addresses, making it easier to navigate to the internet. For example, instead of remembering the IP address 198.35.26.96, we can simply type wikipedia.org or Wikipedia. This is much easier to remember and type. Domain names are case insensitive, meaning wikipedia.org or Wikipedia .org or wikipedia.org in different formats. If we type it like with capital letters or small letters, it doesn't matter. Domain names are case insensitive, so all points to the same location. You can imagine this, for example, if each of you student have your unique ID, right? For example, when I went to college, my ID was something like 133 blah 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 something something. So it was hard for my professor to remember what my ID was, but it was easier for them to know my name. So my name is Mr. Hassan. They can call me Mr. Hassan. They remember my Mr. Hassan, but they cannot remember all the numbers that address to me, right? So similarly, IP addresses, you cannot remember what is the IP address for Instagram, what is the IP address for YouTube, what is the IP address for Netflix. Instead, we can just type on netflix.com, youtube.com, and we go into that website. It's pretty easy and intuitive. So let's talk about domain name system, or DNS. Domain name system is essential for translating these human readable domain names. For example, Netflix is a domain name. There is an IP address for Netflix, but we have a domain name for Netflix, that is netflix.com. So these human readable domain names into IP addresses that computers use to communicate. When you type a domain name into your browser, the first step is contacting the DNS or domain name server to find out the corresponding IP addresses. These are 13 main, there are 13 main DNS root server distributed around the world. So there are 13 locations where it's kind of a logbook where they do the mapping. So for example, if you type in Netflix, the internet doesn't know what Netflix is. So internet goes on and searches in those logbooks like, okay, some user typed in Netflix, but I need to go to some specific address. Now, where is that address? So it looks into the logbook, searches with netflix.com, and then finds out the exact address. For example, 192.168, blah, 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 this number. So, and then it routes to that address, gets the data, and fetches the data and shows it to the user. So that's how it works, domain name servers. There are 13 distinctive root domain name servers distributed around the world, which provide a critical service. For example, IP addresses like 198.4104 run by VeriSign, or 192.203.230.10 run by NASA are part of these root servers. So here are some example root servers: USC, University of Maryland. These are subdomain name root servers. These are basically logbooks where they keep track of which IP address corresponds to which address. We will look into it more details in the following weeks to come during this semester. Now, let's discuss how domain names are registered. To claim an unused domain name, individuals or organizations can register it with a domain name registrar. Registrars typically charge yearly fee to maintain the registration of the domain name. This ensures that the domain remains associated with the registrant. The details of these registrations are managed by ICANN's WHOIS service, which keeps a public record of registration information. When a website is hosted by a web hosting company, that company will handle the domain name server setting to associate the website's domain name with its IP address. This way, when someone types in the domain name, they are directed to a correct website. Additionally, many hosting companies offer services to manage the yearly registration of the domain name, making the process hassle-free for the website owners. Finally, let's talk about the structure of domain names. Domain names are hierarchical with different levels. At the top are the top level domains, or TLDs, such as .com, .net, .org, .edu, .gov. Each country also has a unique country code top level domain, such as .uk for the United Kingdom, .ru for Russia, .de for Germany, .us for US. And for BD, it's .bd, that's Bangladesh. Recently, customized TLDs have also become popular, allowing for options like .church, .pizza, and .music. Below the TLD, we have second level domains. These are usually represents the name of the organization or the purpose of the website. For instance, in wikipedia.org, Wikipedia is the second level domain. In Stanford.edu, Stanford represents the university. Moving deeper, we find third level domains and beyond. These often refers to specific subdomains or subsystem within an organization. An example is cs.stanford.edu, where CS stands for Computer Science Department of the Stanford University. A commonly used third level domain is www, standing the World Wide Web, which typically refers to an organization's main web server. As seen on www.stanford.edu, many organizations allow visitors to omit the www automatically, directing them to the same space. Let's talk about the URLs, which stands for Uniform Resource Locations. A URL is essentially an address of a web resource on the internet. For instance, the URL http://www.cdc.gov/alcohol.faqs, that is frequently asked questions, .htm points to a specific web page hosted by CDC's web resource can include various items such as HTML files, images, videos, and CSS style sheets. Let's break down the different parts of the URL. Schema. This defines the protocol being used to access the resource. Common schemas include HTTP, HTTPS, mail to, and file. For example, in https://cdc.org/alcohol, the schema is the HTTPS. S stands for secure. We will look more into it in the future. Second is the host name. This is the complete domain name that follows the schema. It tells us which server to contact. In our example, the host name is www.cdc.gov. And then third is the path. Path is basically the path specifies the exact location of the resource on the server. In https://cdc.gov/alcohol, the path is /alcohol. Query string, this is optional and appears after a question mark. It provides additional data to the web server. For example, in the URL https://youtube.com/watch, after the question mark, you can see v equals to uu7xcem.dshg. The query string is v equals to uu7xce. This tells the YouTube which video to play. So each video has different video tags or IDs that if you provide the ID, it can play that video. Then the number 5 is fragment, also optional. It follows a hash character and refers to a specific section within a web page. For example, in https://en.wikipedia.org/wiki/URL hash history, the fragment history directs the browser to the history section of the page. Moving on to the common web page errors, there are several types of issues users might encounter when browsing the web. Domain name server errors. This occurs when the domain name server cannot find the domain name, and usually happens when the domain name is not registered. When this happens, users might see the message like, sorry, the website XYZ blah 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 cannot be found. Then second is server non-responsive. In some cases, the domain name is found, meaning the valid IP address exists, but the web server does not respond. This could be due to the server being turned off, undergoing maintenance, or due to network issues such as malfunctioning router. In such cases, you might see error like the website is not responding or could not reach the web page. And there is 404 error page not found. And this is a specific error that occurs when the web server is reachable, but the requested page does not exist. This might happen if the page has been removed or the URL is incorrect, and the server returns a 404 status code, and the user often see a message that indicates 404 page not found. These errors are common, but understanding them helps us better troubleshoot and navigate issues accessing the internet.